Good morning, dear children. Let me continue the class. Okay, children. See, in the last class we have learned in the structure of atom lesson, which I have started, that what do you mean by atom? What are the constituents of atoms? What is molecule we have learned? And the main thing is in this lesson we have learned that how these particles present in the atom, where it present, okay, and the models of an atom. In the models of an atom we have learned that the Thomson's model of an atom. Okay, so let me revise for a few seconds. See, what do you mean by an atom? Atom is a very smallest particles. Okay, so in the atom we find there are three constituents or the parts. Okay, so here at the center we have protons which carries the positive charge and the neutrons will be there. This we call it as a nucleus, and surrounding the nucleus there will be electrons revolving. Electrons which carries the negative charge. This is the structure of an atom tube. Okay, so Rutherford, he experimented or he prepared a model regarding that. They want to see that how actually these structure looks, okay, or by seeing how it have, what is the appearance of this structure of the atom. According to the J.J. Thomson, which is he was a very famous scientist that time, he introduced that the atom is, we get in the form of a sphere or circular. Okay, so this structure of atom is completely covered with positive charge. Positive charge. All this whole atom is completely surrounded or scattered or spread. Okay, so spread or scattered with the positively charged particles. Okay, and he observed that the electrons embedded, electrons in between, he finds that only in some place that electrons will be embedded in the or fixed in the atom. He introduced the structure of atom like that, and he had compared this structure of atom to the watermelon. See, in the watermelon, the red edible part will be there, no red part which we eat. That he gives this one as a positively charged particle will be present in the atoms, which how the edible part or the eatable part of red color we get, which embedded whole complete in the watermelon, and seeds, the black color seeds where we will find in the centers and around the atoms, this will be, he call it as an electron. Okay, children, so this will be a negatively charged particle. Okay, so where there neutron, proton is there. So how many protons will be there? That many neutrons also will be there. So surrounding that, protons and neutrons will be completely surrounding, and the negatively charged like seeds embedded in the atom. He introduced the structure of atom like this. This is called Thomson's model of an atom. Okay, the next model of an atom who was produced by or who was introduced by or prepared by the one more very famous scientist, physicist called Rutherford. So in this class we are going to learn how Rutherford experimented and shows that how there is a structure of atoms will be taken place. Okay, so Rutherford model of an atom. Rutherford model of an atom. See children, before I want to tell you that Rutherford is a student of Thomson's. J.J. Thomson's student. So Rutherford, he was there. Based on his studies, he performed an experiment which we we are going to learn, which having two names for that experiment is. The first one is alpha particle scattering experiment. Means only one experiment, but we can give for this single experiment as a two names. Okay, one is alpha particle scattering experiment. Second one is the names gold foil experiment. Gold foil experiment. Experiment is one only. There is no two or three experiment. Okay. So he prepared the model to show how the structure of atoms will taken place. Okay. But he gave, or we can give this, for this experiment have two names. One is alpha particle scattering experiment and gold foil experiment. Okay. In this experiment, what he had taken, okay, the materials which he had taken. The materials which he had taken as first one is alpha particle, okay, alpha particle, and second one is the gold foil. So that's why he has given this experiment name as alpha particle scatter experiment. You can also say our gold foil experiment also you can say. Okay, he has taken these two very important and very highly reactive materials he had taken. Okay, so let me move on. What do you mean by this alpha particle? What do you mean by alpha particle? See, I hope you have heard in your previous classes that alpha rays, gamma rays, beta rays, UV rays. No, so rays will be there, children. Rays. What do you mean by rays? So it is a radiations. Okay, so it is a how the sunlight will give now. So that is the radiations. In sunlight, which we will get the radiations? That is UV radiation, ultraviolet radiations. Okay, so see here, rays will be there. There are alpha rays. Okay, so gamma rays, beta rays, and UV rays. Or we can also say the particles. Okay, so what is these alpha particles or alpha rays? Yeah, so see there, so these alpha particles are highly radioactive materials. Okay, it is a radioactive particles, alpha particle, because we need not to do or get any knowledge about the beta, gamma and UV. Here we are seeing about the alpha particle. What is alpha particle? It is a radioactive substance or a radioactive particle. Okay. So, for example, helium. Okay. So helium is a alpha particle. Understood? So helium gas or the alpha particles will get. What is the atomic number of helium? 2. Okay. So here, see here children, any of the atom you take, that atom will be having the part protons and neutrons at the center and the electrons will revolve around it. So what is the atomic number? See here. So this helium have 2 protons. What is the atomic number? The number of protons which present in an atom is called its atomic number. Or the number of electron which present in an atom is called atomic number. You can give 2 definitions for it. Okay. So in an atom, let's take helium particle. Helium which possesses the alpha particles in it. Okay. So this helium have 2 protons. At the same time, how many protons will be there? There is a condition that many neutrons will be there. 2 neutrons will be there, and this proton and this neutron, this is called electrically neutral. That I told. If these two will be equal, this is called electrically neutral. So this where it will present? This will present in the nucleus. This is the nucleus. Okay. So to this nucleus surrounding there is a electrons revolving around. Okay. So here the structure of atoms of helium we can represent like this. In the helium, the atomic number of helium is 2, means 2 protons having one unit, the mass, if we want to tell, so each proton having one unit and each neutron having another unit. So 1 unit means 2 mass. 1 unit is equal to 1 unit of proton is equal to 2 mass unit, 2 atomic mass unit, and 1 unit of neutron is equal to 2 atomic mass unit. So 2 plus 2 is equal to 4. So there will be 4 atomic mass unit. Okay, everything should carry the mass, no weight. So what is the weight of this helium particle? The alpha particle which we take, example I have taken helium here for the alpha particle. Okay, so here the alpha particles, it have 2 protons in it and 2 neutrons in it. Actually it was having the electrons, but the electrons will start losing it. When it starts losing the electrons, only the protons and neutrons will be there. Each proton having the 1 unit of mass, weight. Okay, so 1 unit is equal to, if you convert it into the mass, then 2 unit you will be getting. U is represent for atomic mass unit. Okay, then 2 neutron having 1 unit of particle which carries the 2 atomic mass unit. So what is the total atomic mass? 4 unit. Okay, so 4 unit of mass, and this helium particle having a very high energy which starts splitting, which starts bombarding, or which starts giving the particles to the other. Okay, so now this will be having a very high energetic, and the kinetic energy also will be very more. For example, see here children, in the gas cylinder, if we want to compress it, if we want to store the gas, we need to compress it. Now compressibility is one of the special property of gas. Now, so if we want to compress that one, then there is a high pressure gas, we need to pressure it. So if you compress the gas, the particles which is present in the gas will start moving very fast. Understood? So like that, here also, when this helium will be having atomic units of this 4 atomic unit mass, and the charged particles will be there, protons and neutrons, which makes this helium atom will be very highly energetic. So he selected alpha particles to scatter means spread. What? Spread of particles. Because he want to see what is there in the atom. Next, what is the necessity for, I hope we have understood about the alpha particle. Okay, not only the helium will be there, no, you can take thorium, polonium, they are all alpha particles which process. Okay, so those particles which have, or those elements which have more than 90 atomic number more than 90, they are all considered as that highly energetic particles will be there. Okay, next, what is the reason that he had taken the gold foil? Gold means is nothing but it is a metal, we know that. Okay, it is a heavy metal, and why he chose only the gold means because the physical property of, one of the physical property of gold is it is a highly malleable. It is a highly malleable. What do you mean by malleable? If you take gold, if you beat it with the hammer, then we can make as a thin sheet. Thin sheet. This property we call it as a malleable. I hope you have learned this. Now, so this so gold is one of the heaviest metal and one of the highly malleable metal. We can make it into very thin sheet of around 1000 atom, which is very quite impossible, children, for the other metal. Okay, if we cannot make that much thin glass sheet like. Okay, so how we will get this glass sheet now? So like that we will be getting very thin glass sheet which having only the